Proof by induction. I have to be honest with you, is one of the most boring proofs, are just very boring for me. But anyway, we need to know them. Let's go. So h of n is the total number of the dots in the pattern n of the sequence. So h of n, that means total number of dots in a specific number of pattern. So we have to write down the value of what? Pattern 1, isn't it? Because n means number of pattern, and if n is 1, like what we have, therefore we are talking about pattern 1, and we have the pattern 1 very easy for dots. That was simple enough. When n is a natural number, and then h, n plus 1, so mean a pattern, the next pattern, if I'm looking at pattern first, that's pattern 2. If I'm looking at pattern 3, that's pattern, so we get the idea. Can always be found from h of n using the formula. So that is the formula given to us. And then what do we need to do? Use this fact, prove the identity on the grid below. Use proof by induction. So how do we do proof by induction? Okay, this follows a specific steps. So we're going to work them out now. So first part of the step, we are saying for n equal 1. So that means if I am looking at pattern 1, so that means that is 1 plus 1 to the power of 2. And indeed, if we put that in the calculator, we get 4, which is true. That is true. That's the reason why I had that first example. Now, the next part, we are assuming that is true for n equal k. Now, in this place, we're basically replacing n with k. That's all what it is. hk equal k plus 1 to the power of 2. This is our assumption that this is true. In the next step, now this is where we are proving. So we have to, oops, what happened with my pen? We have to prove for n for the next one, k plus 1. So we are taking again the very same thing, and instead of n, we are writing k plus 1. And then again here, instead of n, here we will write k plus 1, and then plus 1 to the power of 2. So that's my second or third step. In the next part, because here they were saying using this fact. What is that fact? That's what it is. So here we are saying to ourselves using this fact, and this fact is, instead of n, we have k plus 1, and that equal, and again that means h, k plus 2, k plus 3. So we are using this fact because they are saying use this fact to prove. Okay? So that means if that is hk plus 1 and that is hk plus 1, that means that we can equal those two. So we can equal, I can add them up. 1 plus 1, 2. Now we are using our assumption. Assumption is that that is h of k. So that's what it is. So again, that's what I am replacing. So instead of, let's get that. So instead of h of k, we are using this fact. K plus 1 to the power of 2 plus 2k plus 3. And from here, we can either go into presenting that in a form of factors. We can factorize, which is fine. But I personally prefer to just basically multiply my brackets, do all the simplification, because what I need to prove is that one side of the equation is exactly as the other side of the equation. That's what I need to prove. So that's what I'm going to do. So on this side of the equation, I have two values in bracket taken to the power of 2, and that equals the first number to the power of 2 plus 2, multiplied by the first number, multiplied by the second number, plus the second number to the power of 2. So that means what? K to the power of 2 plus 2 by 2, 4k, plus 2 to the power of 2, that is 4. And then on the other side, again, to that same thing, and applying that same formula. So that will be k to the power of 2 plus 2 by 1, that is 2k, plus 1 to the power of 2 is 1, and then the rest plus 2k plus 3. So on this side of the equation, that's all really what I've done all I can. And on this side of the equation, I'm saying, well, 2k and 2k together, that is 4k, and 1 and 3, that is together 4. So yes, now both of the sides are exactly the same. So I actually proven that that is true. Therefore, I need to just write the conclusion. So we are saying, therefore, n equal k plus 1 is true, because that's what we were proving. We take an assumption, assuming that it is true for n k plus 1 if true for n equal k, right? And then we are concluding because we have to prove for all the values of n. So then we are saying, therefore, true for all n belong to n. Again, I can tell you only that much. It is indeed very boring to do the proofs. However, we do need to know them because they do come up in our exam.